All right, today we're diving into something really cool. We're talking about how everyday organic waste, stuff left over from farms and forests, can actually be transformed into a new generation of super strong, lightweight materials. Let's get into it.
So think about this for a second. All that stuff left over from farming and forestry, I'm talking husks, straw, even pine needles. What if it wasn't waste at all? What if it was actually a super valuable raw material? That's the big idea we're exploring today.
Okay, so here's our game plan. We'll start with the problem, all that waste. Then we'll meet the natural fibers that could be the solution. We'll see how they're used to create a new material, check out how it performed in some tough tests, and finally ask the big question, is this the future? Stronger, lighter, and sustainable?
All right, first up, the problem of waste. To really get why this research is such a big deal, we got to understand the scale of the challenge we're facing.
Every single year when we harvest crops and manage our forests, we're left with, mountains of stuff. We're talking coconut husks, rice hulls, wheat straw, and for a long time, we've just called it waste. But a growing number of scientists are looking at this pile of waste and seeing an untapped gold mine.
Okay, now for the really cool part. Let's meet the star players in this story, the natural fibers that researchers are using to turn all that waste into something brand new.
First up is our base material, epoxy resin. You've probably heard of it. It's a super common polymer known for being pretty strong. For our purposes, think of it as the starting point, our baseline. It's kind of like plain concrete. It's solid, sure, but the whole point here is to make it even better. We're just going to call it E to keep things simple.
So our first natural helper is areca nut fiber. This comes from the tough, stringy husk of the areca fruit. And its secret weapon? A whole lot of hemicelluloses. Now, that's a fancy word, but it's basically a type of complex plant sugar that acts like a natural glue, binding the fibers together and giving the husk its amazing strength.
And for our second fiber, we're looking at needles from the casuarina tree, the feathery stuff that covers the forest floor. Now, what's really interesting here is that this thick carpet of needles, it decomposes really slowly, and it can actually become a huge fire hazard. So by using these needles in a new material, you're not just upcycling waste, you might actually be helping to reduce the risk of forest fires. I mean, talk about a brilliant two-for-one solution.
Okay, so we've got our ingredients, epoxy, areca nut fiber, and casuarina fiber. Now the big question is, how do you actually mix these all together to create something totally new? Let's break down the process.
Well, it basically comes down to three main steps. First, you have to extract the fibers and give them a little chemical bath, an alkaline solution, to get them ready. Second, you mix those treated fibers right into the liquid epoxy. And finally, you pour that whole mixture into a mold and just let it harden into a solid, new composite material. Pretty straightforward.
So to really figure out what works best, the researchers made 3 different versions to test. First, you've got E, which is just the pure epoxy. Then there's EA, that's epoxy with 10% areca nut fiber mixed in. And finally, EAC, which is a hybrid mix of 5% areca nut and 5% casuarina fibers.
All right, the new materials are ready. Now comes the moment of truth. How do these nature-infused composites actually hold up when you put them under pressure?
First up, we have the tensile strength test. Basically, this just means how much you can pull on something before it snaps. Now take a look at the results. The pure epoxy, E, it handled about 12 megapascals. But look what happens when you add the fibers. The EA sample jumps all the way up to over 17, and the hybrid EAC sample hits nearly 19 megapascals. I mean, that is a huge improvement.
So to put that into perspective, just by adding a mix of both fibers, you get a 56% boost in strength. It's incredible. The natural fibers are basically acting like a kind of rebar inside the epoxy, reinforcing the whole structure from within.
Okay, so it's stronger. But does that mean it's heavier? Well, let's check out the density. Pure epoxy sits at about 1.2 grams per cubic centimeter. But look at the EA sample. The density actually goes down. This is amazing. It means we're making the material stronger and lighter at the very same time, which for a lot of material scientists is pretty much the holy grail.
Just to hammer that point home, adding only the areca nut fibers made the composite 12% less dense. That's a really significant drop, especially if you're thinking about applications where every ounce or gram counts. All right, another really important test is how it deals with water.
And the results here were, well, they were fantastic. These new composites only absorbed about 5 to 6% of their own weight in water. Now compare that to your standard commercial wood particle board, which can soak up a staggering 30 to 40%. It's not even close. This new stuff is way more water resistant.
So, let's pull this all together and look at the final scorecard. The EAC Hybrid, the one with both fibers, gave us that massive strength boost, a whopping 56%. Pretty incredible. Meanwhile, the EA Composite, just the Aeroconut, gave us the biggest weight reduction, making it 12% lighter. And on top of all that, both of the new fiber composites showed excellent water resistance and improved wear resistance. It's a clean sweep. Adding these natural fibers created a flat-out superior material.
So what's the big picture here? What do all these results really tell us about the future of how we make things?
You know, this quote from the researchers themselves really sums it up perfectly. This isn't just about making a cool new material. It's about creating a whole new system that helps the environment by taking something we call waste and giving it a new, incredibly valuable purpose.
So here's the bottom line. The key takeaway is this. We can literally take agricultural and forestry residue, actual waste, and use it to make a standard material like epoxy, significantly stronger, lighter, more water-resistant, and more durable. This is a proven way to turn what we throw away into a seriously valuable resource.
And that really leaves us with one final big question. As we keep searching for smarter, more sustainable ways to build our world, could the future of manufacturing actually be growing right now, out in our fields and forests?